Alright, another graph physics video presentation. Graph science here on YouTube. So, it's gonna be more two-slit stuff. Sorry, but it's sort of important, actually. Really important. The argument, I think, is indestructible that I have, in fact, provided an analysis of the function that just can't be in any way refuted, and it basically blows up any idea that these are waves propagating through space that interfere with each other. That doesn't happen. That it's all being created by scatter, the light's being scattered, it's all straight line paths, and it requires more sources than waves can account for. It's a very understandable pattern. So I'll play the Van Briesen video again, since that was linked to by this Stephen Bro character. It's just so he says things here are just so obnoxious. So he's claiming he made some contribution to the last 3 weeks in terms of me arriving at this simple solution to this famous double slit experiment. And I can't for the life of me figure out what that contribution was. And it's just such a, it's a very bold accusation to make, and it's very derogatory, and it certainly is, if true, would be reason to doubt my honesty and credibility and my character. And so I take it seriously. It's not a fucking joke, asshole. It's a serious accusation. So it starts with then I realized these were not his questions. So when I ask these questions about why physics didn't do this, or why physics didn't do this experiment, or why are they presenting the evidence in a certain way, he's saying those are somehow not my questions, that somebody else has already asked them, and that I'm just copying their questions. I mean, that doesn't even make sense. But where's your evidence for that, fuckhead? I mean, again, it's kind of a serious accusation, plagiarism, all this kind of crap. You can't back it up with anything. I know, because I'm here. I made the videos. I'm the one who sat here and had the realizations almost in the process of making the videos. So, I know your accusation is horse shit. It's a fucking lie you made up, because there isn't any evidence for it, because I should know, because I was here living my life, fuckhead. Alright, so he says he makes other people's work sound like his own. Again, it's just such horse shit. There's nothing. I honestly say, I haven't even thought about Stephen for a year, since the holiday thing, in any relevant way. I was subscribed to his channel, so I was interested if he was doing any experiments, and he hadn't done anything. So exactly how was his input in any way important? The last I remember seeing a comment was him commenting to some Skyrim guy having a conversation about how wide the slits are. On his transparencies, because they give you these numbers that don't seem to correlate to the actual dimensions. They give you something in millimeters, that's a millimeter, right? And it's really micrometers or something. But anyway, so he says he makes other people's work sound like his own, which is just, like I said, those are bold words. Back them up, or I have every reason to be pretty pissed off. Anyway, he deleted my comment about variable double slits. Now I don't even know what that could possibly mean. Alright, in terms of deleted your comment that I didn't see, I blocked you from my channel when you posted on the fucking Trolls channel. Okay, that was it. I was now disinterested in any input you had. Okay, so yes, your comments disappear on my channel. Does that mean I saw them? No. I mean, I can sort of prove that, when I view comments, I'm viewing them on all comment pages. And guess what? The sub-threads don't show up here. So I have to go look in the sub-thread to see some new comment in some sub-thread. So you having some douchebag conversation with some other douchebag is your business, okay? It's not my problem. So, that's all I can say about that. Sorry, we will get to the 2-slit. Where the fuck was it? Alright. I just want, I can't figure out what he's talking about. He deleted my comment about variable slits. I have many interesting videos of variable slit experiments. He said it was irrelevant. Okay, so there isn't nothing on his channel. There's no variable slit experiments I can find. And, you just watch some of the videos and you'll see the point, in the sense that the quality is so bad that there's not much you can glean out of the videos. So he did not read it out before deleting it, whatever that means. So, I mean, I'm just saying, he says he saved his comments. Well, just repost your comment on the troll page and we can see what the fuck you said that's somehow relevant to the analysis I've done. And I'll bet it's not going to be at all relevant. Okay, then he bragged about it being his idea 3 weeks later. What idea? Saying, why had Walter Lewin not thought of it? Yeah, so I said it's just a side remark. I just pointed out, they have the variable single slit. They could vary the double slit by just having the same mechanism with a wire in between. I think he even said the word wire in between. So he says I stole that from somewhere, just making the point that why don't they ever make variable double slit, where they move the outside surfaces. Well, I guess the real reason is because the outside surfaces are very irrelevant to most of their analysis, because it's not even in their cheap math. The cheap version of their math doesn't even have a variable for the distance of the outside slits. They're totally irrelevant to the math, which is sort of funny. Anyway, so, and again, he says I bragged about it as an idea. I didn't. It's completely irrelevant. It's not part of the analysis. It's not even important anymore. We don't even need to do it anymore because I already can predict exactly what's going to happen. So why do I need it? Oh, that's right, I don't anymore. Saying why, okay. Had not thought of it, saying there is a lack of creative thought. Well, no, there's a lack of willingness to even suppose something else could be true. And the real accusation is they construct the experiment to sell their idea. So they quote mine, essentially, the way of presenting the experiment to make their analysis work, when if they showed it as it actually happens, as it actually is, their analysis would fail. Okay. Pretend it's his idea. Let's see. So he keeps repeating the same. Even though he deleted my message, I always save them and record all my videos just in case. I don't know what in case could happen. Many people, not just Gary, cheat their way through life. So there's another accusation that I've cheated somewhere. It's just fucking disgusting. He even brags about path length difference being his idea. It is ancient. So again, I'll point out the difference. I've made no such accusation that somehow path length difference is my idea. No, my idea is that you have to view the pattern with the right perspective, that is on a parabola, and that you can see quite obviously the only thing that changes in the experiment is the length of two lines I drew. I didn't even use the term path length difference. So again, you're just such a liar. You have no evidence for this accusation at all. What just a horrible, ragged piece of shit. Anyway, cheat their way through life. They disgust me. Well, I'm likewise, lying sack of shit. He even brags about, it's ancient. It is wave theory. See, again, he says it's wave theory. I'm proving it's particles. I'm proving the only point sources that work are scatter point sources. You can't have a wave in those places. The wave wouldn't be created in those places. That's what's being proven by me, asshole. So clearly, how would I steal an idea that isn't accurate and doesn't produce the results? Why would I do that, idiot? Anyway, he pretends it's his idea. Well, like, obviously, no idea related to waves would be my idea, asshole. He gets away with it. I mean, just amazing. Gets away with what, fucking liar? God, I just, the more you read, you just say, who the fuck is this asshole? Hell, you could even buy, so I read this before, a teaching device. So why don't you draw a picture of this teaching device and show how it was used? Because nobody's teaching with it. So why was the teaching device a failure? Why isn't there a single video record of anybody ever using this teaching device? Alright, so anyway, like I said, I already briefly read this, so let's go to his channel. There's no video with a variable slit anywhere in here. Okay, and the only slit videos he has, this one is mostly about the pattern that's reflecting off the slits, right? So it doesn't say much about anything. So that's happening because of the internal reflection off the plastic. And then he does a joke video that doesn't say anything. And then this video is about mirrors reflecting like back and forth. And so, yeah, it's interesting, but it doesn't really have any applicability. And this one is just more talk about his mirror crap. So there's nothing here. Okay, there's no insights provided, no analysis provided, no anything provided that could be of any use. So anyway, he's made this stupid video that is incomprehensible. So if somebody can tell me what his exact accusations are, you know, if they can sit through the video. I mean, playing songs, he takes it as a big joke. So it's a big joke to make accusations impugning my personal character. That's a big joke to you, you little fuck. Well, it's not a joke to me. Okay, and I'm really not interested in your little musical interludes. You know, that's like 1942 internet. You know, parody videos are so old and so tired, and so who the gives a fuck? Okay, so yeah, fuck you. So anyway, there's just nothing here. And like I said, what exactly are you claiming credit for? So I proved that waves can't be the right answer, and he's claiming it was his idea, even though he claims waves are what caused the phenomena. So that's the irony of this, which is hilarious. So anyway, let's play the Van Briesen video, and we'll go through it step by step and see, you know, if you people can get it. You know, it's pretty obvious what's happening.
Welcome to Electronline, and now we're going to start a new series in a lot more detail about light interference. So
he's talking about lots of detail. So yeah, 25 videos. That's a lot of detail. And unfortunately, he starts with just complete nonsense. So not even close to what we know reality is. So that's the, you know. And so people are saying this isn't a propaganda perspective. I mean, when you start, you know, already engineering something, you know, where you've left a whole bunch of facts out, really important ones, and pretending the reality is something far different than the actual reality, what's the point of that except for a propaganda or to mislead?
Here we have an example where we have a double slit, and it's called Young's double slit because the experiments were first done by Young and the write-ups were done by Young.
Right, and the write-ups that were completely inaccurate. So let's understand, Young didn't get the right pattern. It's 1801. Oh, Jesus. Camera failure. Anyway, 1801 gets just barely anything that you'd even call something worth even paying any attention to at all. I mean, it's just so bad that you would almost say, oh, just don't even bother. It's such a bad vision of the actual experiment. So Young's analysis is that, you know, he's a wave guy, and so he draws these two waves interfering, and he gets this rough idea of a pattern, a rough idea of on, off, on, off, on, off. Now we know, okay, the modern humans know that's not the pattern. That when you do the double slit with something more than an infinitely small opening, right? The only way you can have it work their way is these openings would have to be almost infinitely small. That is smaller than a wavelength of light. They have to be so small that the difference between this length and this length would be almost nothing. That's the only way you can get a nothing pattern. Otherwise, you're going to get the traditional double slit pattern, which means you're going to get this complex pattern, okay, of pattern, then no pattern, pattern, and then no pattern, pattern, and then no pattern. So there's two patterns here. There's one pattern doing this, right? Well, almost in the, it's almost in the frame, almost. Okay, so one pattern's doing that. This is just how much light, amplitude of the light, how bright it is. Okay, and then you have this little, you know, pattern. Okay, so there's two patterns making up the slit, double slit experiment, not one pattern. And you can make them both sit on top of each other. That is, you can make this pattern almost as big as this pattern, and so you'd almost get no pattern. But like I said, you can only do that by making these slits incredibly small, near zero, you know, kind of thing. So what I realized, okay, so that's the truth, right? So that truth is nowhere in his initial description. So first off, he doesn't even describe to you the fact that the double slit creates two patterns superimposed on each other, and that the real feature that's responsible for the connection to quantum mechanics is the idea that this spot right here somehow goes from being light to being dark. You know, when you have one slit, it's light, and when you have two slits, it goes dark. When it really doesn't do that. You know, that the truth is nothing ever goes darker. The only thing you can do by opening and closing these slits is making something brighter, but never darker. Alright, so I guess that's good enough for now. Play a little bit more.
How light interacts when light shines through a double slit. At the far end here we have a screen at a fairly large distance away from the double slits. The distance between the slits, called D, is very...
Alright, so another context that I brought up, that, you know, I had this conversation way back, I think back when I was talking to Piros about this 7 years ago, is that this pattern should be viewed, alright, technically, you know, if you're going to look at a pattern coming off of something, you... the truth is the pattern really should be viewed on a round screen. Just like if you were projecting a very widescreen movie, you'd have to project it on a screen that arced, you know, that was a parabola, or everything would get very distorted. You know, everything gets too, you know, something that's this size here ends up being this size over here when it's projected over there. So you don't project technically. If you want to see the right pattern, you want the math to actually work. So he does a ton of math in these videos, and none of the math he's giving you is right. None of it would get the right answer on this flat screen. So if he uses this flat screen and he gets an answer for what location, where it should be, like 3 meters from the center, or, you know, 3 feet, you could say, would be more realistic. Like this bright spot should be 3 feet from the center. His answer will be wrong if he's projecting it on this flat screen. It's not going to be the right answer. It's not going to be in the right place, and it's not going to be the right size, and it's not going to be the right intensity. It's not going to be any of those things, because you've distorted it by projecting it on a flat screen. Its real dimension is going to be the length of this circumference. That's the only thing that matters. is this length. You can sort of get the idea that if I did cut this into equal sections and then I projected it on a flat screen, so if you had equal pi sections cut out of this and I projected those on a flat screen, you could understand that even though these were the same size, one of them would end up much bigger than the other one because of the fact that you're projecting at a much longer distance and it's diverging much more with that longer distance. And you're going to get a distorted view. You're not going to see it the way it actually is. So this is a fundamental part of the mechanics of the system, right? This is something kind of Newtonian, right? Kind of classical in terms of just understanding the rules of projection. And none of the physicists say it. Not a single lecturer at universities, when they talk about this experiment, not one single one talks about the fact that the math they're giving you only works if you understand the screen has to be a parabola, a perfect, it has to be the same equidistant from some point, on both sides. That you always have to keep this distance equal. Same, it doesn't look equal here just because I didn't draw a good circle. But, the right circle would be something like that, I guess. And if you don't do that, the math doesn't even work. So, the whole thing is just such an engineered, for their purposes. Because if you looked at it this way, you'd recognize how obvious it is that the two lines, from your two waves, right, they're going to be exactly the same length here. And they're going to be the most uneven here. So the one going from here and the one going from here are going to have the most difference in their length here and the least difference here. And that all you're doing is going from this distance to 0. And each place is just an amount of distance here. And that's the whole solution to the question of how many bars are you going to get. You're going to get exactly how many bars equal to this, how many wavelengths fit in that distance. And that's it. That's all there are. Whatever wavelengths fit in here will tell you how many bars they're going to be. And they never, not a single one of these physicists, ever tell you how many bars are in the whole pattern. They know exactly how many. You can predict exactly how many bars there are. Whether you can see them or not see them, whether there's enough photons landing for you to see them is a question. Obviously, you're not going to see the bars over here and over here because of less light. But the fact is they're there. They're calculable, and every single one of them is accounted for. And so the pattern isn't at all ambiguous or mysterious or any of that stuff. You just count how many wavelengths fit in the distance between the point sources, and you're done. And let's understand, the point sources aren't, I shouldn't bother saying this already, but I'll say it now. Why leave it for a surprise for later? The point sources in the double slit experiment is not two waves, a wave here and a wave here, and you take these centers and you take radiuses out of here. That won't work. That won't create the two patterns. The two patterns can only be created by 4 point sources. So the waves would have to be here, right on the surfaces. Half over the surface, half not over the surface. Why would your Huygens or any other system create a wave that's half over the surface and half in the opening? Why would any of your silly wave theory create waves like that? Oh, they wouldn't, of course. And of course, they never consider it 4 waves in the double slit experiment. But there is 4 sources. These 2 sources perfectly account for the big pattern here. So these 2 sources create the components, that create the big pattern. And these 2 sources define the small pattern. And that's it. Experiment solved. And there's no room for waves in here. There's no mechanics that make waves understandable. Even if I could make 4 little waves here, it wouldn't work. Well, it would work. But they'll never do it. They'll never show you 4 little waves. So I'm just saying they're never going to do it that way. Because waves wouldn't be on the surfaces. So anyway, just saying.
Tiny compared to the distance from the source here, the slits, to the screen on the other side. Now what's going to happen is when light shines through a very...
Now, they all say that, right? I mean, Feynman pointed out it's a very long distance to the screen. You know, that's not the part where they screw it up. The part where they screw it up is they say when I close one of these slits, I get a pattern over here. When I close this slit, I get a pattern over here. That's the part they screw up. Another mistake that's just so simple. It's so mechanically simple a mistake to make. I mean, a 1 millimeter difference is not spreading, okay? It's spreading the individual photons, but it can't spread the place it's projecting the image to. The total place that all the photons go can't move anywhere. So it's 1 millimeter difference here. You won't see it here. So if I close one of the slits, I'll get a pattern. If I close the other slit, I'll get a pattern. Those two patterns will be right on top of each other. 1 millimeter of difference.
very small opening, light diffracts. That's the case in any kind of wave.
All right, so we have light diffracts, which doesn't mean anything, right? Because diffraction is just this idea that they say a straight wave goes in and somehow a round wave comes out. That's diffraction. So they call that diffraction. And then if I screw that up and I make the diffraction uneven, okay, by putting interference in it, they still call that diffraction, which is bizarre. So they don't use these words consistently, so they don't mean anything.
The sound wave goes through a small opening, it will bend around the corners and go in all directions beyond the opening. If water wave goes through...
So again, that's the context they're using it in. When we know that the real context is that these are just point sources. So obviously I can take a point source and I can have scatter. And I can say it scatters in any one of these directions. Now obviously, okay, that could be called diffraction. It's spreading. So scatter can create a diffraction pattern, right? No problem. That's exactly what scatter does. It diffracts. And yet they think it can only happen because a wave went round. And we know, like I said, in water we know why it goes round, because there's friction and it pulls on the medium. So there's a reason why the light bends. But we don't have any reason for, photons. There's no theory that says photons are stuck to each other, and because I slow one photon down, the rest of them get slowed down. There's no theory for any of this nonsense. So I'm just saying the words really don't mean anything because they haven't explicitly defined them. They're saying diffraction is a wave function. I'm saying clearly you can just say if I have a point source that scatters light in any one of the forward directions, it'll scatter some way forward, that it does exactly the same thing. And yet they say this can't happen. It's somehow physically impossible, okay, for scatter to look just like a wave. Well, of course it can look like a wave. It's not a wave, but it can look just like it.
A small opening, the waves will go all the way around the corner in all different directions. And light waves are no different. When light waves...
So again, this comparison is kind of silly. They're not the same thing. It is different, and it's fundamentally different.
Light waves go through a small opening, they will what we call diffract, bend around the corners and go in all different directions.
So again, we know light can scatter. So that's the simple explanation, scatter.
Which means that the light that goes to the top slit will essentially shine on all of the screen over here on the other side, and the light going to the bottom slit will also shine on the whole screen here on the other side.
Alright, so that's again just kind of doing this oversimplification where we know that if the slit has any width at all, that's not what it'll do. Okay, so we know scientifically a small opening all by itself will create diffraction, okay, and that it's going to have interference in it. That is, a single slit is going to create a broken pattern. All right, and I have to make this slit insanely small for the pattern to be big enough, so big that one notch, okay, is that big. So if I was to make the arc drawing of it, the arc would be something like this. Like light would go to this part of the arc, then there'd be no light, and then light again down here. So that's all you would have. But I have to make the slit width, okay, something like, you know, the light's at 500 nanometers, let's say. So I'd have to make the slit width 1 micron or smaller, or micrometer. Does it call it a micrometer? Well, whenever. It'd have to be that small, which is so small that you wouldn't hardly see any light at all get to these surfaces. So to make the pattern that big, where it just goes, where all you see is this, right? Just that, just one big lump. I have to make the slit so small that no light gets through it. So it's not very practical, and you never really see that. You always see some fringe, because they have to make this thing bigger. You know, they have to have at least 3 wavelengths or 4 light wavelengths worth of light getting through here before you can even get enough photons to see the pattern. And that means for every wavelength you're adding one of these notches, which means you're reducing the size. So if I double the size of this slit that creates this pattern, then I'll get a pattern that has, you know, 3 fringes. And I might not see these fringes. These would be the only ones I see. If I projected it, I'd only see a little lump and a big lump and then a little lump, right? Like the standard mush. But it's just about the size. The distance between the slits entirely decides what the pattern's where the pattern's going to be. And obviously the frequency of the light, because that tells you how many wavelengths will fit in here. So obviously if I go higher frequency, that means it's 300 nanometers, you know, for blue light. Then obviously you can get more inside of the same opening. If it's 300 meters, I create more fringes. That means they're closer together. It all fits. Alright, let's play some more.
Which means the light patterns from both slits will come together everywhere along this slit. But if we then take a look at the slit, what we'll find is we'll see regions where the screen is lighted up and you have a bright spot, and then there's regions where we have a dark spot, and it interchanges.
Alright, so, and what he's showing obviously isn't the double slit pattern. The double slit pattern has 2 patterns. And even if you were to look at it really close up, the 2 patterns are going to be visible as soon as you get to this spot. You'll have these hard darks, okay, that are created. So if you just look at this little narrow part, yeah, you can draw it like he's drawing it. But if you look at the whole pattern, that's not the real pattern being created. So again, it's a way of framing the evidence to make it look like what they want to sell you. But if they showed you the real pattern, you'll know that can't possibly be the right answer. That 2 waves are not creating this pattern. 2 sources can't do this double pattern thing. It has to be 4 sources. And they have to be in places that waves won't be. Waves aren't going to be right on the surfaces where I predicted this whole phenomenon was created on the surfaces. I've said for years this is the 4 surface experiment, and the 2 slit is the 2 surface experiment, because it's always been about the surfaces. And now I can prove it.
Go from bright to dark to bright to dark to bright to dark, and on both sides of what we call the central maximum spot. So in the very center, they call this the central maximum. That's the spot directly across where the 2 slits are, and that's where the 2 beams come together. You'll see a bright spot. Then on either side of it, we have a dark spot. Then we have a bright spot, dark spot, and bright spot, and so forth. And that's called an interference pattern.
Right. So we call it an interference pattern because it's on and off. But my argument is, you know, this is more of them forcing the jargon now, because we don't even have a word for this pattern other than the interference pattern, because that's what they called it. And nobody tried to call it something else, and so that's a real problem. What it is a pattern, but it's a pattern of reconstruction of photons. And all you're really doing is saying these 2 sources provide some energy in this shape. Okay, and then these two sources provide energy here, here, here in these little spots. And when you combine those, when all four sources are in phase, you get a bright spot. When all four are in phase, if only three, well, it's a dark spot. If only two, a dark spot. Only, two, a dark spot. You have to have all four of them in phase to get these bright spots. And when all four of them aren't in phase, then you get this hard dark, and this hard dark, and a hard dark.
The question now is, why do we have an interference pattern, and how do we actually analyze it? And how?
So it's not an interference pattern. It's photons are broken by obstructions, and you reconstruct photons. So it's constructive reconstruction. Where did you put the photons, the pieces? Where did you send the pieces? And where do the pieces restore the phase? Having the pieces is one side of the equation. Okay, you have to have the A, the B, the C, and the D. Having the pieces is one thing. You have to have those. If you don't have the pieces, you got nothing. And then the other part of it is restoring them into phase. And that's it. The two elements. Pieces and then phase. So the same number of pieces are going to all these locations. The dark spots have plenty of pieces. They have four sources of pieces. But the four sources are out of phase with each other. So nothing gets put back together.
How can we find the intensity of the light at various locations on the screen relative to where the two slits are? Well, for one thing, what we have to realize is that there is a path length to travel from the slit to a spot on the screen. And notice the spot directly across from the center. And what I want to show is that even the...
So he's saying it, with this wrong drawing. So I've shown you what the real point sources are that explain the pattern. He's drawing a wave here and a wave here, implying that the center of those waves are the sources, and drawing lines. That won't get the right answer. And that's, I think that was actually demonstrated by, what's that, the videos that were bought up by Microsoft, Khan Academy, conceded that, and then had to redo the video because they had to concede if you go from these two waves, you won't get the right pattern. Those two sources won't work.
So the way I have this drawn here, it doesn't appear that those two lines are parallel. In essence, they really are, because as I've drawn here...
Well, okay, see, this is more nonsense, right? Because, those are explicitly parallel, right? Well, I mean, he drew them to the center point, but if he drew them straight across, then he could just show they're the same length. So, yes, obviously this length and this length are the same length. Now, if I take the parallel lines and I move them to the center of that point, then obviously the length of the lines are still exactly the same length, but they're not parallel. So he shouldn't say they're essentially parallel or effectively parallel, because they're not parallel. The fact is, though, they are the same distance from parallel, so it means the lines are the same length. They're bisecting their parallel position, so bisecting a parallel lines would be the same length of line. They would be still the same, they still would have equal length to each other. The lines wouldn't be the same length, they'd be the same, they would equal each other. They wouldn't be the same as if they were parallel.
The distance between the slit is usually very, very tiny, and the distance across here is very large. Usually the ratio is somewhere in the order of 1,000 to 1 or something like that. So it's a huge distance to the screen, very small distance between the slits, so that essentially these waves are, in all intent and purposes, parallel to each other. So when they reach the other side, they've traveled a distance from the slit to the screen, parallel to each other, and they come together, and you can see that.
So again, they're really not. So then parallel doesn't really mean anything, because as pointed out, the only thing that matters is this distance. The length of this line and the length of this line, right? And you just add those two lines up, and this is the difference. This difference is all the difference. And all you're just saying is that this difference is the maximum here, okay? And it's the minimum here, it's 0. And all you're saying is how many places along this arc is it a wavelength of difference? So how many wavelengths are in that extra distance, and that'll tell you exactly how many times you have reconstruction of a photon. It'll tell you exactly how many bars there will be.
Because this spot right here is directly across from the slits, the distance traveled by those two light waves, the path of that light.
So they keep saying it again. This is their propaganda, their story told their way to make it look like something. And it's just not right. I mean, it's like them doing the little animated Bible stories or something. You know, you can select pieces out of the truth, all right, and put them in a collection and make them look like something. But it's not the truth. Seems like is not is like.
Right there is exactly the same. So when the waves were in phase at this location, they will still be in phase when they reach there. Remember with waves, we've studied that in mechanical waves, when waves come together, if they're in phase, there will be constructive interference, and when they're out of phase, there will be destructive interference. What do we mean by out of phase? Well, for example...
So, again, all this argument comes down to is that understanding. And clearly, phase can be understood without ever thinking about a wave. And you can just understand phase as being a time and space. So I could shoot bullets out of phase. I can shoot anything out of phase. That is, without them being in alignment. And that's the only concept here at all that matters is phase is not a wave function again. They're forcing it to be something only waves do. Phase is something frequencies do. And they can be lined up or they can be out of alignment. And if they're out of alignment, they're going to be received as something different than they're in alignment. So if I was to send this to, for example, a radio, okay, and you knew that these were two different frequencies, this frequency and this frequency, well, the radio can't tell because the radio is going to see this frequency. That's what the radio is going to see. It's not going to be able to decipher this out of, this one or this one out of what it's receiving. So it's just about phase is important. If I put them in phase, then it can see it, okay, because it keeps this frequency stays alive if they're in phase. And if they're out of phase, you kill that frequency. It doesn't exist. Continuing.
If two waves come together, and they're like this, and they reach the same point, and they're completely cohesive, and they're in phase at the exact same spot in their wave when they come together.
So you just talk about throwing rocks, right? So if I throw the rocks at exactly the same time and they hit something at exactly the same time, you could understand that they might be able to affect a change. So if I throw one rock, it doesn't knock it over. Okay, but if I throw two rocks at the same time, it will knock it over. So now you can understand how important the phase would be, because now if I throw this rock a little slower, it just doesn't work, because by the time this rock hits, it tips it a little, but it rocks back before this one hits. And so you just keep doing the same thing over and over again. But if I hit them close enough to at almost the same time, the idea is once it's tipped this way, I am hitting it with more pressure, so it tips all the way down. I have enough energy to tip it over. So these are simple arguments that can make why phase matters. That's why phase matters. And the same is true for how a photon is going to be able to be received by an atom. Is it has to be the right frequency. We know all the atoms have resident frequencies, all the electrons. They have to be hit in a certain sequence, and if you don't hit them in that sequence, they're not going to make a reciprocal photon. They're not going to reflect it. They're not going to transmit it. There's lots of rules, and they're all phase dependent. But it just really has to do with the energy hitting them in phase. Doesn't have to do with any wave.
Call that constructive interference, and as a result, the two will be additive, and we have what we call constructive interference, where the magnitudes are additive, and you can see that this will be the result of the two waves coming together. When that
So obviously what I'm arguing is the no bullet spaces don't add. Okay, so if I'm shooting bullets, you can obviously understand that, oh yeah, where the bullets are, that's one bullet plus one bullet equals two bullets. The empty space between the bullets doesn't go, that's plus empty space, and this is one empty space, and now I have two empty space. Now that doesn't happen. So there is no magnification of the zero places, obviously. 0 plus 0 doesn't equal 2, 0.
happens at the central maximum point, we see a bright spot there because the two light waves constructively interfere with each other and therefore made it a bright spot. But what happens when...
So we know that it's just really about not any constructive, it's about additive. So you know that you've got two parts in phase, you remade a photon, you're back in business. So it could be just as simply understood as the slits break the photons. Okay, so if the photon was 6 things, you could understand, or even 5, but anyway, you could understand. So if a photon was 6 nodes, 6 bits of a wave, and I broke that, and now it was only 2 broken pieces of wave, well, you can understand that if I don't put them back into a 6 node, if I don't have them in phase where they're continuous, that they're all at the same frequency or distance, then it won't be a photon. But you can understand that I could send 3 from this side and 3 from this side and put them back in the right order, okay, and it will create a photon again. So it's easily understood as what it obviously even looks like. You're creating an impediment, it breaks the stuff as it goes through the impediment. The photon has very wide polarization, remember. The photons have separation in space, and so pieces of them are easily broken off. You break off a bunch of the pieces, and then you put the pieces back together again in phase, and you get a light spot. You remake a photon. It's intuitively easy to understand, and it's also more explicitly correct. It predicts all you want to know. It'll give you every answer you want to know. It predicts what their math doesn't predict. It tells you exactly how many bars there are. Okay.
One wave comes in, and the other wave comes in, and when they come in, they're exactly 180 degrees out of phase. 180 degrees out of phase. Well, when that happens...
So they say exactly, but none of this has to be exact. That's why these points of light are not like, oh, here's a single little strip of photons that are on, a single little strip that's off. So this is another detail they completely ignore because it really isn't consistent with their theory. But if you really look at the little pattern, if you look at one of these little blocks of light, it's a little block of light. It doesn't get gradually on and gets brighter here in the center and then gets a little duller at the edges. It doesn't do what it's supposed to do. Gradually on, gradually off. It really is a bar of light, and substantially a pretty continuously lit bar of light. And what it was really saying is this is how much range in polarization, how much you can be out of alignment. So you can be a little bit out of alignment. So instead of these things being exactly 3 inches between them, let's say 3 inches, 3 inches. Yeah, this one could be 2.7 inches, and this one could be 2.6, and this could be 3.4. So they could be a little bit out of a perfect alignment, and they'll still be a photon. And so that's why the bar has a size. And then there's a small space that's dark. Okay, because it's allowing a lot of pretty out of phase stuff to still be a photon. But once you get past that, once you go past 3.4, well, now it's not a photon anymore, so now you're in the black zone. And then you go light again. But you'll always see the pattern has more light. The light occupies more volume than the dark spaces do.
They will destructively interfere with one another, and the result is that you have no wave at all. So they will completely destroy each other. There'll be no energy to be seen at that location, and that would be the places where you have a dark spot.
So he said it, no energy seen at that location. They haven't done that experiment, by the way. So that's another one of the lack of curiosity that I complain about. That Stephen Bro says is an unoriginal question, a question I'm asking. But yes, if you did photograph it in infrared, so use a green laser and photograph the pattern on the screen in infrared and see if you can detect a heat difference, a temperature difference, because I am arguing that energy actually is hitting all of the locations. Energy goes every single place in the same amount. And the question is, did you put the energy back together again? So when 3 of these things hit, that's still 3 bits of energy. That's still 3 heat units. Okay? So when a photon hits that only a frog can see, that photon's a real photon, and it's going to have a real reaction with the atomic structure. So it'd be interesting to see some infrared. Somebody must have an infrared camera and be able to do, like I said, this is perfect for Ken Wheeler. He's got the camera, so he should do it. It might not work, in the sense that it might not be enough temperature difference, but that would be something you could, you should be able to tell that by just photographing the beam hitting different surfaces. So by controlling what surface you project it on, you should be able to find something that doesn't dispense temperature too easily. So something that's a little bit of an insulator would probably be a good choice. But yeah, it's an experiment that really should have been done. And as far as the evidence indicates, nobody's ever done it.
On the screen. How does that happen? Well, take, for example, this first dark spot right here, and let's draw a line from this location to the first dark spot, and from this location here to the first dark spot. So maybe I should use a different color, otherwise it gets a little confusing here. So let me try my purple line. So let's draw a purple line.
And obviously on the infrared camera, they'd have to use a green filter just to make sure none of the green light is being detected by the camera. So, but yeah, that's like the ABCs of doing photography. You should know that.
Over here, and the other purple line over there. There we go. So you can see that a little bit better. Now, what I'm saying here is that the distance to go from there to there is not quite as large as the distance to go from there to there. There's a slight additional path length, a slight additional distance the bottom light has to travel to get to this point.
Right. Now, they all use this same math, right? And then you draw a normal between those two to find out what the exact difference in the length of the line is. But the difference is always going to be some portion of this original distance. This is the only distance difference you got, is this length of the opening. And you'll take that distance and take just some percentage of it going from maximum to 0. That's all there is. There's maximum to 0, and there's a certain number of notches of wavelength. So if you took a ruler and you put your normal line on here, and you had your ruler sticking over that line, by the number of notches, the number of wavelengths, you could just watch, you just move your ruler up, and you could just watch the ticks where the ruler, the notches on the ruler match, and that's where the bars are going to be. Twice as many of those. So you always have to double that distance just because it does it on both sides. If you want to do the whole arc. But yeah, for half the arc it's the same as the distance. So this will tell you the truth for one side. You just take the ruler and move it up, and every tenth of an inch or whatever you were using as markers, they'll tell you exactly when the tenth of an inch hits that line, that's a bright spot. When the tenth of an inch hits that line, it's a bright spot. When the tenth of an inch hits that line, it's a bright spot. That's simple.
Compared to the top light. And because of that, when the two waves get there together, they will no longer be in phase. If it's completely dark, that means when that second ray gets there, it had traveled a little bit farther. How much farther? About a half a wavelength. If it had to travel a half a wavelength farther, and they were in phase at this point, there will be a half a wavelength out of phase or 180 degrees out of phase when they get to that point. And when they're 180 degrees out of phase, the two waves will destroy each other. There'll be destructive interference.
So again, if they did this by the normal way you would do it, you know, the normal size slit openings that produce a good visible pattern. The good visible pattern, obviously, if when there's a whole bunch of these little bars in here, and it's a tiny arc, really, you can know that your pattern is being made out of thousands. You might have 1,000 of those little bars. So when you see a nice bar pattern with lots of little bars in it, you have to understand that, okay, you're seeing 10% of that arc, and it might have 100 in it. Well, you know, then you have to multiply that, and so there actually is 1,000 of those little bars in the whole pattern. And that's the normal. See, they've blown it up, taken it so there's, oh yeah, there's 4 centimeters of difference between where the light and the dark is. Well, that's with these infinitesimally small slit openings. Create more distance, you create a lot more bars, a lot more wavelengths of difference in the length of the lines.
And you'll see no light at that point. How do we calculate that extra distance? Well, if you draw a line perpendicular to this ray right here, from this point right there, you can see that from this point to this point, from these 2 points onward, that's exactly the same distance. Again, imagine that these are really essentially parallel to each other, because this is...
It's just silly. Again, they're not essentially parallel. That's like saying essentially infinite, or I mean, it's just such it's not very good physics to say something like that, because they're clearly not. And again, the easier way to see the difference is just to draw this arc and say, you know, when the two lines are on phase, you know exactly how far this line is, right? You know, it's the radius times the pi, and you got the circumference, and that's all you need to know. Once you have the circumference, you can just say it's, you know, 3 millimeters on that circumference.
Is so small compared to that distance right there. So these two lines are parallel from that point to that point. From these 2 points, the distance here is exactly the same when you get to that point. So this here is the extra distance traveled. This is considered what we call the extra distance. And how do we find out what that is equal to? Well, if this is the distance between the two...
See, right, exactly. They should just say this is always just going to be a fraction of the distance that you're of the experiment. So when they're just doing an impediment, it's just the size of the impediment or the size of the opening. But in the double slit, you have the catch where the distance is going to be the distance between the two outside surfaces. That's going to be the biggest difference. That's going to be the longest line. Obviously with 2 slits, this line goes way over here. You know, it's a lot longer a line. The farthest away line has a lot more bars in it.
Slits, and this is the angle, call it theta, that these 2 rays make with that spot right there, so from there to there. And again, remember that this is the same angle for this ray as it is for that ray, because...
So again, their point sources are in the wrong places, so this math won't even work. So you can say this is sine theta, this is it, you know, but unless you use the actual math, which is the actual distance between the two outside surfaces, you'll never get the small pattern correct. So first off, you can't do the double slit and get the right pattern, that is the real pattern, without 4 point sources. Obviously 2 point sources won't create the right pattern. So he's not even doing math that could possibly be relevant to this experiment. It won't get the right answer.
So close together. So we're talking about this angle theta right there, which is the same as this angle theta right there. So this is the opposite side. This is the hypotenuse. And so we can say that extra distance is equal to the hypotenuse d times the sine of theta. Now,
so I don't have to do
sine of theta.
I don't have to do any of that sine of theta stuff, right? I don't have to first do this geometry, figure out what a sine of theta is. I can just take the absolute distance and multiply it and divide it into the circumference of the distance. So I use the distance away from the target, create an arc, multiply times pi to get the circumference, and just say 1/4 of that circumference, obviously, is the length of my line, and I know exactly how many notches I'm going to have, and I know how long each one of them can be. So I'll know exactly how far apart they're going to be.
Small quantity, because theta is a very small quantity. These are very, very tiny angles. These are very small distances compared to this distance right here. So since it's a very small angle, we can say that this is approximately equal to d times the tangent of theta. When I say approximately, it's probably within 0.1% or something like that. Very small difference. And then we can realize that if we call this distance right here from the bright spot to dark spot, we call...
So it's really just an equivalency relationship. You're just saying, here's the opening size, here's the dimension I'm looking at. And then when I project that on a wall, there's a certain magnification, okay? And I'll know exactly what that magnification is by this length. So this length tells me what the ratio is going to be. And I'm really just setting up a ratio. And I'm saying, I know it's a wavelength that makes a bar in here. I know exactly how long that is, and I'm just going to compare it to how long this is, and it's going to be exactly the same thing as the wavelength difference. So this wavelength equals this distance. So the relationship is so, you don't even need the sine theta stuff to figure that out, because you already know that the bars are going to be the same size as the wavelengths that fit in the distance. So you just divide the distance by the wavelength, and then just figure out how big you've magnified it by distance.
Well, this distance equal to y, a distance away from the bright spot, and we call this distance from here L. This would be the opposite side. This is the adjacent side of the angle theta. So we can say that this can also be written as d, which is the distance between the two slits, times the ratio of the opposite side divided by the adjacent side. So
right, so we just did the distance between the slits, right? When he knows he drew his wave in the middle of the slit. So why didn't he do distance divided by a half? Why didn't he cut that distance in half? Because he's comparing two lines that are coming out of the center of the slit. He's not comparing two lines that are at the surfaces, right? So you know it can't be the right answer.
we can say that the extra distance traveled by
the math obviously doesn't parallel his drawing. His drawing is saying one thing, the math is saying something else. The math is saying the 2 points I'm comparing are at the surfaces, yet his drawing is showing it out at the center of a wave. See, that's why the wave theory doesn't work. The wave is in the wrong place. The wave has to be again, I can just draw the slit. All right, you can see one of those, right? Yeah, it's funny. The other line's not showing up. That's really bizarre. It's right there. Yeah, so the board's crooked, I guess. Okay, so there's your slit. All right, he's showing it with, he's got two slits, so he's got the wave, but he's showing the center of the wave. Okay, and he's saying that's the point source. He's comparing that point source to, say, another wave here with a point source, right? Well, that looks a little vulgar. But what he's actually going to use as the distance is this distance. So he's putting the center, okay, the point source center, right on the surface, which means this wave would have to be drawn here, and this wave would have to be drawn here. The wave would have to be half over the surface. Clearly, scatter is where that would happen. Scatter puts the wave in the right place. Scatter puts the source of diffraction in the right place. Scatter works. Waves do not.
Second ray compared to the first ray would be equal to d sine theta, which can be said to be d tangent of theta, which is d times this distance divided by this distance. In other words, if we know this quantity right here, dy over L, that's the extra distance traveled by the second wave. And if that extra distance traveled is, for example, a half a wavelength, if the extra distance traveled distance is equal to 1/2 of a lambda, 1/2 of a wavelength. That will then put those two waves.
So again, we know that that extra distance is always just going to be a fraction of the distance. It's always going to be a fraction of d. Some d minus 1 wavelength, 1 lambda. D minus 2 lambda. D minus 3 lambda. That's all it's ever going to be, is some lambda portion of d. The number of wavelengths tell you exactly how many bars there will possibly be.
Phase, a half a wavelength out of phase, a half a wavelength is 180 degrees, and at that point there would be destructive interference. However, if we look at a point a little bit further up on the screen, notice that would require a bigger angle, and let me use a different color. Let me see if my red pen works right here. There we go, it kind of works. So now we're looking at a larger angle theta, okay? So d sine theta, if theta is larger, that means there's going to be an extra distance traveled, which is now greater. So my extra distance traveled is now greater. And that's going to be the sine of theta equals the tangent of theta equals y over L, which means y is now bigger.
Right, and it will tell you where the center point will be, but it's going to, you know, because he's doing it by the rule of the wavelength, okay? But it won't tell you intensity correctly. It won't tell you anything else correctly because you're distorting it, because you're stretching the pattern as you project it on a flat screen. You're distorting the truth.
And if the extra distance traveled now, instead of being a half a wavelength, is now a full wavelength, then the two rays are back in phase. Then the extra distance, if extra distance traveled, is equal to a whole wavelength, then the two rays are back in phase. Then instead of destructive interference, we are back to constructive interference. And if we have constructive interference, we'll see a bright spot on the screen.
See, that's another irony of the experiment, right? Is that they always project it on a flat screen for, you know, lots of reasons. I've done it. It's just easier certainly to photograph too. But the point is that it also gives you an illusion that the pattern is getting dimmer and dimmer in some real way. Like somehow it gives you the illusion that it's getting more dim than it would look like if you had the arc screen. So if you arc the screen, the intensity would be brighter because you wouldn't be casting the photons on such a large surface. So the amount of surface you're hitting the photons on would be the same here as it would be here. The amount of surface would be the same, so the intensity would look the same. So the pattern would look even more like a bunch of just on, off, even more bar-like if you project it on a round screen.
Again. Then again, if we make the angle even bigger, again, we're not really making the angle bigger. What we're doing is we're simply looking on the screen, and we're going a little further up the screen, and at that spot, it becomes dark again. Well, why does it become dark? Because now the extra path length will be 1.5 wavelengths for the second wave, for the second ray instead of the first ray, if the extra distance is, and let me write that down. So if the extra distance is now equal to 1.5 lambda, then the two waves will be again a half a wavelength out of phase, a half a wavelength.
Right, but if he set it by measurement, if you did it by measurement, these measurements would start to get more and more off. You're supposed to be 3 millimeters, or 3 centimeters difference in distance, and it would be 4 centimeters here, and 5 centimeters out here, and 6 centimeters, and 7 centimeters. You'd start stretching it. So again, their math can't even fit being projected on a flat screen. The math doesn't work. They keep talking about how it's all perfect and it fits and it's all, they've sewn up all these edges and they can put these nails in the coffin. They've tested and made sure that all of the theories are dead. No, not even close.
180 degrees means there's destructive interference, and we'll see another dark spot. And then if we look a little further up the screen, to a point up there, so that the rays go up even steeper than that, the extra distance traveled will now be 2 lambda. So we could say that if the extra distance traveled is equal to 2 times lambda, then again you'll have a bright spot on the screen. And so forth and so on. So if you keep looking higher and higher up, we can see that we have, again, at that point when the two rays...
And so forth and so on, as if it goes on like that forever, and the true answer is no, it doesn't. It's entirely a finite system. It all happens within this 90 degrees of arc, and it just has to do with this difference, and once you've used it up, you've used it up. It's a finite thing in a finite space. It doesn't go on and on and on like that. None of that happens. So again, this is just part of, to make it more mysterious, to make it more not the facts. So he doesn't do the real pattern. He doesn't put the waves in the right place, that even the math dictates where they're supposed to be. The center of the waves are supposed to be right on the surfaces. He doesn't put them there when he draws it. The whole thing is just a distortion to sell wave theory. And if they did it honestly and they did it the way it, mechanically correctly, not like their teacher taught them, right? Again, they're not doing this on purpose. He's not getting this wrong on purpose. He's getting it wrong because it's been ingrained in his brain that this is the way you're supposed to view this thing. And he never thought about it. He never thought about, oh yeah, I'm distorting it by projecting it on a flat screen. Oh yeah, I'm implying infinities. No, there's no infinities. Oh, of course there has to be more than two sources here, because two sources don't create the right pattern. He's just never thought about it. And that's just amazing.
Come together from...
It's amazing how deep the propaganda is. Wave theory propaganda. They just can't imagine the world that doesn't have Jeebus in it, right? Evolution is just too foreign. I ain't related to no Minky. I mean, that they just can't imagine it for some, reason that escapes me, because I couldn't imagine it any other way. I couldn't imagine it their way at all.
The two slits right here, the extra distance, the higher up the screen you go, the greater the extra distance, and then you ultimately go from a half to a full to 1.5 to 2 to 2.5 to 3 wavelengths of extra distance travel, which that causes the light here to ultimately become constructively or destructively interfered, and because of that we'll see bright and dark spots on the screen.
So you break photons, you either remake them or you don't remake them. You either put them back in phase or you don't put them back in phase. The pieces go everywhere. You either have pieces in phase, you have pieces out of phase. That's all it is. Done. Debunked, finished, and obvious. Like I said, the obvious, it's just obviously wrong. Again, the math says the point sources are the surfaces. The math clearly saying it. The point sources are the surfaces. It's in the math. That's what that frickin' math is saying explicitly. It doesn't say, no, the point sources are in the middle of the wave, the wave source. No, so they draw it completely not accurately. Okay, so let's just understand. That's what I'm complaining about. These are teachers, these are professors, and they're making these just almost idiotic mistakes. The idiotic mistake of drawing the two lumps in the wrong locations. The idiotic mistake of drawing it from a center that isn't in your math. I mean, that's an idiotic mistake. And yes, you fooled me for years. You fooled me with your nonsense, your broken example of reality. I trusted you were obeying basic rules of logic when you weren't.
The general principle of that, and that's how we know that the path length difference causes a phase difference in the light reaching the screen, which therefore causes light and dark spots to appear on the screen. In the next 10, 15 videos or so, we'll show you an exact methodology of how we can calculate where those spots will occur. And not only that, we'll be able to calculate how the brightness and darkness changes.
So he's going to just talk about calculating again. And what he's going to do is he's going to point out that there's, well, forget what I just said. Forget what I said in that first video, because we're not going to bother with this math anymore, because this math doesn't work. And so we're going to change the math. And eventually we're going to give you math, and we're never going to talk about wave centers and all that stuff anymore. We're not even going to talk about point sources. But what we're actually going to do, though, is exactly what I did, which is figure out that these two outside surfaces are creating the little pattern, and the two inside surfaces are creating the envelope. And he won't even say that, even though that will be the obvious conclusion, because he's going to turn this two-wave experiment into a 4-point source experiment. I probably should play this series again. Maybe take the best out of it or something. But anyway. Enough of a video, I think.
As you look at different locations on the screen as a function of how the light interacts with each other when it comes to the two screens. And I'm fine.
So the light never interacts with each other. The pieces just get broken off, they fly somewhere, and they either get put back in phase or they don't. Period. That's it. Nothing else happens. You could almost say it's like the stuff is made out of stuff going in all these directions, and you break it, and so some of the pieces hit the wall going this way, and then some of the pieces hit the wall going this way. And the only places you see the stuff, the two stuff, is where one hits this way and one hits this way. If two hit this way, you can't tell. But if they hit this way, then you can see a little star. You say, ah, that's different.
Finally, we'll go ahead and change it to 3 slits, 4 slits, 5 slits, and see how that pattern changes with additional slits. And in the end, we'll do n slits, any number of slits, and see what the...
So know what it'll be? It'll be end surfaces. It won't be end slits. It'll be end surfaces. I mean, they'll call them slits because they'll pair them, right? But it's going to be end surfaces. That's going to be the math that works.
pattern will look like. What you'll end up seeing is that there'll be this sine wave function of the brightness. So here we have a bright spot, then it's a dark spot, a bright spot, a dark spot. You can see how the brightness and the brightness and the darkness ultimately changes as you look higher up or lower down the screen away from the central maximum.
So he's not really saying anything here, and what he should be saying is what you'll find is with these different patterns that this pattern becomes very irregular. It ends up having harmonics in it, okay? Little patterns on top of bigger patterns, on top of bigger patterns, on top of smaller patterns. Lots of patterns.
We'll be able to come up with equations and exactly describe what the intensity will be at any location as a function of angle or as a function of position on the screen. So,
right, so it will not work as a functional position on the screen, so let's understand they'll get that part wrong. The math will be wrong because they're projecting it just like movies. If they project a widescreen movie on a flat screen, you're going to get huge distortion. So obviously the math won't work if you do that.
if you're interested in this and you want to understand this better, take a look at these videos. I'll try to explain it all for you. This is how we do it.
So he's going to explain it all for us, and blah, 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 blah. And all it really is propaganda to sell wave theory. And that's all it is, and I've shown it for all it is. And so, you know, all these detractors, all these people who say it's the most proven theory in the history of mankind, and we have all this evidence, we've proven our case, only an idiot. You have to be a science denier, you have to be a flat earther, you have to be a religious kook, you have to be some sort of person with an agenda, not to be totally persuaded by our broken math, our broken analysis, and our clear bias. They're clearly biased. They believe in this wave theory, and they're contriving, they're forcing the evidence to match their theory. They're not being fair to it, they're not fairly analyzing it, they're breaking fundamental rules, simple rules. Like I said, I shouldn't have to explain to a physicist that they can't project their image on a wide flat screen. I shouldn't have to explain why you can't do that. Right, to a physicist. That right there you've broken a rule. Right, so I will endeavor to persevere, but frankly I've done it on this subject, okay? I have unraveled one of their little magic tricks. I've clearly illustrated it. I've shown you the videotape, the pigeon up their sleeve, the gimmick, the horse shit, the dodge, the deception that was used to fool you to think there was something magical happening when there's nothing magical happening. It's completely explainable with little straight line forces, scatters the right answer, the point sources are the surfaces, as I've always contended. The end, it's done. Okay, your fake story has been exposed. It's just a fake little three-pig story. It doesn't work. Photons aren't fucking waves. I pulled the nails out of the coffin. The thing you nailed into the coffin is now alive, okay? And you have to account for why you threw nails on, you know, why you were trying to bury it too soon. Particle theory lives. All right, and you know, you can't lie it out of existence. Maybe I will title the video "Particle Theory Lives." Yeah, okay. Anyway, till the next time and such.